I'm Nasser Wasim, AI Solution Architect here at DDN, and today I want to address one of the most critical bottlenecks in enterprise AI, which is retrieval performance delays in production pipelines. Let me start with the fundamental. RAG, which is retrieval augmented generation, has become the standard architecture for grounding LLMs in your enterprise knowledge. The workflow is very straightforward. You ingest the document, break them into chunks, you create vector embeddings, and when a user asks a question, you retrieve the most relevant chunks to provide the context for the LLM's response. Sound very simple, right? But here's where the enterprise deployment hit a wall. In a production RAG pipeline, especially hybrid implementation that combines vector search with keyword matching, the chunk retrieval process becomes your primary bottleneck. Think about it. For every single user query, you are pulling 5, 10, sometimes even 15 chunks from your object storage. And at a scale of 50,000 queries per day or 100 of concurrent users, those retrieval operations compound exponentially. And this is the problem we're going to solve today. What you are seeing here is our reference architecture, built on NVIDIA's RAG blueprint. It's a production-grade end-to-end RAG pipeline. Documents flow through semantic chunking using NV ingest and get stored in object storage. And we are testing both AWS S3 and DDN Infinia in this demo. They are indexed with FAST or Milvus, depending on the client preference for vector similarity search. Then we have integrated NVIDIA NeMo Retriever component and also a re-ranker that improves the relevance significantly, and guardrail for enterprise content safety, and finally Nemotron 70 billion parameter model as our language model. Now, let me be transparent about this comparison. This is nearly apple to apple comparison. Same data, same chunking, same retrieval pattern, same S3 API call. The only one architectural difference is AWS S3 is cloud-based over the internet and the buckets are stored in North Virginia, while DDN Infinia is on-prem in our data center in Colorado Lab. However, we are accessing remotely over the internet. What we will see that Infinia's performance gains are so substantial that they translate even in a distributed enterprise deployment. And what we will demonstrate today is not just a fast storage, it's an intelligent architecture that unlocks your RAG pipeline true potential, where the retrieval speed matches your AI processing capability. And for the complete transparency, I have written the whole architecture detail for anyone to look into that. Before we dive into the actual test, we have a live configuration tab to configure both AWS S3 and Infinia. And keep in mind, it's not a pre-canned demo and no cherry picking results. What you are seeing here is a live performance measurement. And in the interest of time, I've already configured Infinia and S3. So both storage providers are set up with the production-grade credentials with an access key, secret access key, and the endpoint URL with an identical parameter where applicable, and we can see that all of the connections are running successfully. Now, this dual approach is not just for benchmarking. It's designed to answer the question every CTO asks, what's the measurable difference? When you are processing millions of documents or storing petabytes of embeddings and serving thousands of concurrent users, you need a quantified performance data. And that's what this architecture delivers. And remember, AWS is on cloud and Infinia on on-prem with remote access. However, we are accessing both the buckets via same S3 API call. So keep that architectural difference in mind as we look at the results. And here's the bucket, AWS, and here's the Infinia bucket. Let's see this in action. I'm going to upload a multi-page PDF that gets intelligently and semantically relevant chunk for an optimal retrieval. So you can upload PDF, Word, text file, spreadsheet, PowerPoint, CSV, because this is a multimodal pipeline. I'm also going to use NV ingest, which is NVIDIA's library for semantic chunking. So let's upload a PDF. All right, we have the results. So there was only one document. There are total roughly around 60,000 characters. 132 chunks have been created by leveraging NVIDIA's NV ingest intelligent semantic chunking. So the results are very astonishing. You can see that DDN Infinia, took like 0.0033 second per chunk, whereas AWS took 0.118 per chunk. So that means we know DDN Infinia is 35.7x faster than AWS. That means 97.2% upload time you can save just alone. Now, the most important thing that matters for the enterprise when you are processing thousands of documents daily, and a lot of people think about one dimensional, and that is it's just about faster upload. But in reality, it's about pipeline throughput. How quickly can you make the new information readily available for your AI consumption? So that means it's about GPU efficiency, it's about efficient architecture, and it's about optimizing your pipeline and infrastructure. So let's take a quick test with some multi-size chunks and see what that look like. And we're going to test from 1 kilobyte up to 8 kilobyte, representing everything from brief metadata to a dense technical content. And we have the results. So with 1 kilobyte chunk, the result says that Infinia took 0.0043 per chunk and AWS took 0.2858 second per chunk. So again, we are 66.7x faster and reducing 98.5% time. And again, with the 2 kilobyte, you can see over here, we are 35% faster. And with 4 kilobyte chunk, we are 35.1 times faster. And all of these results, shows that, whether it's a 1 kilobyte, 4 kilobyte, 8 kilobyte, medium large or extra large, you can see that DDN Infinia maintains a consistent performance gain at any split of a chunk. And this consistency is extremely critical for production workloads where predictability matters as much as the raw speed. Let's talk about real-time AI at scale. This is an event-driven continuous ingestion pipeline, and it's the difference between an AI experiment and an AI-powered business. Every second, this system is going to monitor our Infinia bucket. The moment a document lands, whether it's a contract, report, customer data, anything, it's going to process automatically and immediately available for your preferred LLMs. So that means no batch processing delays, no overnight ETL jobs, instant knowledge availability across your entire organization. Now I'm going to upload multiple documents to drop into an Infinia bucket. Watch the numbers and it will tell you the story that is around up to 90% faster compared to a cloud storage, but it translates that into a business terms. Number one, your team get answer in second, not hours. Number two, your expensive AI infrastructure like GPUs, compute never sit idle waiting for data. Number three, you're processing 10 times more queries with the same hardware investment. So let's take a quick run here. Now look at these impressive numbers here. Our performance number is consistent around 95% compared to a cloud storage even at scale. All right, we have already ingested the document. So now we can begin asking questions. So for example, let me ask a question here. What are some of the core value proposition of DDN Infinia? We have re-ranker and guardrail already active, and we're going to use NVIDIA Nemotron 70 billion parameter model, though we have a few different LLM option out there as well. So let's ask this question. All right, we have the results, and looking at the results looks pretty accurate. And keep in mind, this is actually drawn directly from the ingested document. Now, let's try to understand the process here. It began with a vector similarity search that retrieves semantically relevant chunks from Infinia using Nemo Retriever with their similarity scores. And then we use NVIDIA re-ranker, which is going to basically re-rank these chunks based on a true semantic relevance rather than cuisine similarity. And of course, we have NVIDIA guardrail to ensure the content safety. Now, look at the right-hand side, which is very critical metrics in time in RAG pipeline, which is time to first byte comparison. DDN Infinia took 0.1277 second in total for the entire query, whereas AWS took 1.4051 second in total. That means we are 11 times faster than AWS. And that also reduced the retrieval time by up to 90.9% time, which is huge. And this speed translates into a real world impact. Your GPU cluster costing between $3 to $5 per GPU per hour cannot afford wasted retrieval time, because each second of the delay across thousands of queries means thousands of dollars in unnecessary compute. And just as importantly, user experience improved dramatically as well. A response in 130 milliseconds feel instantaneous, while one at 1.3 or 1.4 second feels laggy. And this difference drives adoption, and ultimately adoption fuels your ROI. And DDN Infinia achieved this at enterprise scale, and thanks to its highly efficient and intelligent architecture we have. All right, let's translate these technical metrics into a business outcome. And again, this is not just about faster storage, it's about transforming your AI economic. And let me give you a real quick example. Let's say for a mid-sized enterprise running 50,000 queries at $3.5 per GPU per hour, with DDN Infinia's performance advantage, you can eliminate approximately 2.5 hours of daily GPU wait time. That's $132,000 in annual infrastructure saving. And when you scale this up to 100,000 queries per day, which is very common in a Fortune 500 deployment, and you are looking at $250,000 in yearly GPU cost reduction. But the impact extends beyond the infrastructure, because faster response time improves user productivity. And the research shows that each 100 millisecond of a latency reduction in inference pipeline directly correlate with 1% of the productivity improvement. And we have developed a custom scenario calculator that lets you model your specific deployment. And in this calculator, you can adjust queries per day, concurrent users, number of chunks ingested per day, GPU cost, and RAG specific parameter that will instantly help you see your projected ROI. And most enterprise organizations achieve positive ROI within 4 to 6 months, with an advantage compounding as you scale. So let's deploy this reference architecture in your data center and measure the ROI firsthand. So please contact DDN to run this benchmark with your document, your query pattern, concurrency limit, and your current infrastructure cost for a measurable business outcome. Thank you so much.